The capture of light for photosynthesis is done by photosystems, which are structures made of protein complexes and photosynthetic pigments, clustered on the membranes of autotrophic organisms. In the case of organisms with oxygenic photosynthesis, they have two kinds of photosystems, the photosystem II and photosystem I, which have as a main photosynthetic pigment the molecule of chlorophyll. An important aspect of chlorophyll is that it is relatively easy to promote its electrons of its center ring to upper orbitals for the absorption of the energy of photons. But it's more difficult to remove electrons of the center ring of chlorophyll. If the chlorophyll is placed in a center surrounded by proteins, then the local environment around the chlorophyll is enough charged to remove electrons from the center ring of chlorophyll to be transferred to other electronic receptor. To this structure is given the name of the reaction center. The problem of placing a chlorophyll molecule in a core surrounded by proteins is that the chlorophyll becomes less effective in being excited by light, because a big part of its surface is covered by proteins and cannot capture the photons of light. The plants have resolved this problem in a very ingenious way. Several hundreds of chlorophyll molecules are clustered around the reaction center. Nevertheless, none of these molecules of chlorophyll can lose electrons, but they can push their electrons to upper orbitals when absorb the energy of the photons of light. As these electrons return to ground state, the energy released is enough to excite electrons in adjacent chlorophylls to higher orbitals. Therefore, the energy obtained from the initial photons jumps between chlorophylls until by chance it jumps to the central chlorophyll. Here, the energy is sufficient to push electrons out of the central chlorophyll of the reaction center. In this way, the energy obtained from the initial jumps of the photons between chlorophylls resonate until the photons have the opportunity of jump to the central chlorophyll. Thus, the accumulated energy is enough to push the electrons out of the central chlorophyll. The chlorophylls that are not inside of the reaction center collects the light in the same way that an antenna can do, and canalize the energy towards the central chlorophyll, which is oxidized by the loss of one electron. Thus, the electron hole made will be filled with an electron coming from the breaking of the water molecules done during the photosynthesis. Finally, it is necessary to say that the antenna system is even more clever, because other pigments such as carotenes, phycoerythrins, and phycocyanins also form part of this antenna system, which means that plants can capture almost all the spectrum of the visible light.